Hi, my name is Sean Kang. I'm from Farmlytics team, and my teammates are Sui Lim, Ho Kai Shen, and Yi Song Yuan. In this video, we are going to present our preliminary round idea and prototype. The domain we selected is AI and data science, and our focus will be on case study 2, AI-driven solutions for sustainable agriculture. The 6 factors below are the reasons why we select this case study. First of all, global food security challenge. The increment of world's population nowadays causing the food production needs to keep pace to prevent hunger and malnutrition. However, small-scale farmers who produce a significant portion of global food often face challenges such as unpredictable weather, resource inefficiency, and pest outbreaks to maintain the crop's production. Next, there are many challenges in traditional farming methods. Conventional farming largely depends on the experiences and intuitions, making it difficult to optimize the resources such as water, fertilizers, and pesticides. Farmers often lack of access to real-time data insights that could help them to improve their productivity and adapt to changing conditions. In order to overcome these challenges and issues, AI plays a crucial role in transforming agriculture. For example, AI can analyze vast agricultural data sets to predict crop yields, optimize irrigations, and detect diseases earlier. Next, machine learning models can provide farmers some personalized recommendations to improve their productivity and reducing waste. AI precision farming also ensures efficient use of resources, contribute to sustainability. As our alignment with SDG Target 2.3, AI solutions can help to double their productivity and income for small-scale farmers by providing them data-driven decision-making support. For Target 2.4, AI can promote sustainable food productions by enhancing soil health, optimizing water usage, and improving the resilience to climate change. Besides that, the next reason we select this case study is to bridge the digital divide for farmers. Many farmers, especially in rural areas, have limited access to technology and the internet. AI-driven platforms with offline capabilities, SMS alerts, and simple interfaces can make these insights accessible to all. Last but not least, AI-driven solutions for agriculture can also provide them a sustainability and environmental benefits. For instance, AI can minimize the water wastage, prevent soil degradation, reduce excessive use of fertilizers and pesticides, and contributing to environmental conservation. On the other hand, smart crop rotation strategies powered by AI can maintain the biodiversity and improve the long-term soil fertility. That's all from me. I will pass the presentation to my teammates now. Thank you.
Hi, my name is Yi Song Yuan, and I'm going to be doing the demo presentation right now. First of all, the user will be able to sign up here, log in here, and once you're logged in, you'll be directed to this main page. User can edit their personal information by clicking the icon here. And then you can go to the settings and edit your settings preference. The user can also add their own farms here. And then click on the robot icon. Any questions you can ask the robot, or you can upload an image and ask the robot as well, also can. Moving on, click on the calendar. There are 5 total features, and all the features here, the robot assistant will be helping you. Task to do. Weather will be shown as a weather status. Plant rotation will be color coded for each different plant. Water will be indicated by 1, 2, or 3 water droplets. And humidity will be shown by percentage. Moving on, click on the crops item. Here we will actually let you know all about the fertilizer information. Click on add task to do. Here you can choose your own farm, choose your task, choose the date, time, item name, and also the quantity. You can add more tasks as well, or you just confirm for these 2 tasks also can. Moving on, click on Kuala Lumpur. You can click on achieve. Here you can see all the harvested crops. Moving back, all the data here will be shown in a simple form. You want to know more, just click on it. So first of all is the weather status, then the water status. You can select on your auto or manual system, and then you can toggle on and off. Moving on to the crop status, you can actually click on the pest identification, upload your own photo, select your plant name, select your zone, and then click on next. You can see all the disease symptom and also the strategy. Click on proceed. This one will show you the fertilizer part, and then click back. It will go back to the main page. So moving on, click on real-time monitoring system. You can select your farm, select your zone, and then you click on next. Here you actually see the whole thing. It display out your harvesting date, your weed level, and also your soil condition. The 2 bottom button is the same. Moving on to the manual monitoring. Here you can upload your own photo, select your plant name, select your zone, click on next. Here will actually display the same thing. So moving on, click on the soil level. Here you actually see all your fertilizer information, your fertility status table, and also the amount you needed for each of the component. And then lastly, click on the map icon. Here you can see the overall area of your farm. You can hover on the red dot to see your sensor, or you can just read through the sensor table below. That is all for me. Thank you.
For proposed solution, firstly, we implement the predictive analytics by using the historical data to predict the optimal planting times, irrigations, and potential pest outbreaks. And second will be the computer vision for crop health monitoring. With the image recognition, we can detect the sign of disease, nutrient deficiency, and pest investigation. And a real-time dashboard will be also created to visualize the key agriculture insight for farmers. For the crop rotation, a recommendation system will be implemented to suggest the best crop based on the soil health, climate condition, and historical trends. In order to make the precision farming, the risk will be notified to the farmers for the risks such as drought, pest infestation, or soil degradations. Smart crop rotation strategies will be also suggested to the farmer to maintain the soil fertility and biodiversity. The computer vision will also be extended to do the early disease detection by uploading the image of the crops. For the sustainability and resource optimization, smart irrigation system will be used to optimize the water usage based on the soil's moisture level and weather forecast. And automated drip irrigation will also be implemented to ensure efficient water usage. Pest control advisory will be given to the infestation, and all AI-based soil analysis will be adopted to recommend the right time and quantity of the fertilizers to prevent the overuse. For the system architecture, the front end we use the Flutter Dart in order to create the front end of the apps as well as the website. And then for the back end, we use the REST API, Amazon S3, and the PyTorch. For the storage, we use the Supabase and the PostgreSQL. In order to access the satellite imagery for temperature, air moisture, and weather prediction, firstly, we use the Fast API to create an API endpoint to trigger the entire data pipeline. And second, we'll be using the AWS S3 to access the Sentinel-2 satellite imagery. And followed by that, in order to retrieve the data of temperature, pH value, and the elevation data for coordinates, we respectively use the NASA Power API, ISRIC, Stoichkrics, Grids, and Open Elevation API. And lastly, we use a Keras API from the TensorFlow in order to train a small neural network to predict the outcome based on the data. So now more breakdowns to the soil sensor. For the sensor, we use the capacitive soil moisture plus the DS18 B20 temperature and electric conductivity sensor. And for the microprocessing unit, we use Arduino with the connectivity of LoRaWAN with a gateway, and provided with the rechargeable battery of solar, and the cloud storage will be the AWS IoT Core. And for the water irrigation sensor, we will use the LoRa-based nodes with ESP32, LoRa gateway connect to the internet with the Raspberry Pi, solar power nodes with battery backup, MQTT communication to the AWS IoT Core for monitoring and control, as well as the mobile app built with Flutter. Lastly, for the computer vision camera, we use the Raspberry Pi camera module version 3 as the main camera with the Raspberry Pi 4/5 processor, and the storage will be 32 GB plus micro SSD, LTE module, or Wi-Fi for the connection. And for the detection, we use the media pipe module of computer vision.
Hi, I'm Kai Xuan, and I'm going to present our business model of our solution. So first, I'm going to talk about our revenue streams. Our first one is the freemium model from farmers. So for the free access, the basic features will be weather updates, soil health insights, general farming tips, and some limited AI-based recommendation and some offline alerts. This is suitable for those rural farmers that don't have that much money and can benefit from our AI solution. And for those who subscribe to our premium subscription, they will have advanced AI-driven insights and personalized advisory, and they have access to expert consultation via chat, video, or call. Yeah. So our next revenue stream will be business to business and enterprise model. Our first one is agribusiness and cooperatives. So we will provide bulk pricing for large-scale farmers and farming associations. So they have custom AI analytics for supply chain management and productivity optimization. The next one will be our agro input companies, basically those companies that sell fertilizer, seeds, and pesticides to farmers. So we may have paid promotions to recommend their products to farmers and provide insights to tailor their products to the farmer needs. They can benefit from the data from the farmers. Our third one is FFB companies. So we can provide supply chain analytics to monitor crop availability. So our third one will be government and NGO partnerships. Our first one will be public sector collaboration. We can collaborate with the local government to provide subsidized access for farmers. And also we can provide training programs that are funded by the local agricultural ministries. And also if you partner with NGOs, we may get grants and development funds, such as we can get funding from United Nations agencies such as FAO, World Bank, or IFAD for sustainable agricultural initiatives, NGO collaborations for capacity building programs. Our last revenue streams will be data monetization and analytics. We can sell anonymized farm data insights to agri-businesses, agri-insurances, and microfinancial institutions. They can make smarter and bold decisions based on the real data that we provide. We can earn money from that. Also, we can collaborate with insurance and financial service. We can offer them data-driven insights so that they can get better financial access for the farmers. Next, I'm going to talk about our key partnerships. So firstly, we can partnership with the farmers, unions, and agricultural cooperative to drive adoption and ensure our wide-scale implementation of our solution. Next, we can collaborate with technology and telecom companies to provide internet access, mobile integration, and offline features to farmers. Third one, we can collaborate with university and research institutions. So we can collaborate with them to develop our AI model and to conduct agricultural research. The fourth one, we can collaborate with global development agencies such as the UN, World Bank, or FAO to scale the platform in developing regions. The last one will be e-commerce and supply chains to connect the farmers directly to the markets. Okay, next we'll talk about our cost structures. So basically, we need to allocate costs to three different parts of our solution. First one is the development and infrastructure. We need to develop our AI models and machine learning models, and to develop our data collection infrastructure such as IoT sensors and mobile applications, and also our cloud storage. The next one, we need to allocate cost to our daily operations, such as our AI training. Our AI model need continuous maintenance and data feeding. Also, customer support, farmer training, and marketing. The next one will be scalability. We need to allocate cost for our regional expansion and also the localized AI models, web-based AI, and offline access. Okay, the last one is our scalability and long-term vision. So in our short-term plan, in the next 1 to 2 years, we will mainly focus to pilot projects in key regions such as those underdeveloped countries such as Africa and South Asia. Our next 3 to 5 years, we will aim to expand our solution to multiple countries with B2B and B2G presence. In our long-term vision, in the next 5 years, we will aim to be the global AI-driven agricultural platform with blockchain integration. I'm going to present our competitor analysis. So the first, I will talk about our key competitors. We have researched some competitor and their offerings, and what's their strength and what is their limitations, and what we can take advantage of. Our key differentiation of our solution. So our first feature is we have AI-powered yield and soil health predictions. Our advantage is we are more affordable and we are more accessible for smallholder farmers. Our next feature is AI-driven pest and disease detection, and our advantage is we combine computer vision and satellite remote sensing. Our third feature is smart irrigation and water management. Our advantage is we offer cost-effective irrigation solutions using AI and IoT. Our competitive advantage, meaning the market gaps that we can fill. The first one is affordability and accessibility. Most AI solutions are too expensive and require high-tech infrastructure such as IoT and very expensive drones. Our solutions are very cost-effective for small farmers. Our next advantage is offline and low-tech support. Most of our competitors rely heavily on internet access and cloud computing, while our solution offer offline alerts and web-based AI assistant for rural farmers with limited connectivity. Our third one is all-in-one AI-driven insights. Our competitors usually focus on 1 or 2 aspects, like some focus only on water irrigation, some only focus on pest disease detection. But our solution integrate every kind of insights, every kind of data to assess crop health and water management, etc. Our last advantage will be government and NGO collaboration. Most prior competitors, they only focus on commercial farming, but our solution we will actively find partners with government, NGOs, and microfinance institutions to bring AI benefits to these underserved regions. So our competitive positioning, our first one is our target audience. Our target audience will be smallholder farmers. Our pricing strategy is we will provide freemium model for small farmers and B2B and B2G subscription. Our third is market entry. We will focus on emerging markets such as Africa and South Asia before scaling to developed economies. Our unique selling proposition, we are affordable, AI-powered, farmer-friendly platform with real-time insights, multilingual support, and offline accessibility. That's all from the competitor analysis. Thank you.
Our applications targets at the market of small and medium farmers with the non-commodity plantations such as the fruits, herbs, and vegetables, which comprise of 33% of the market. But the application can also be extended to the whole market of commodity plantations such as the paddy, coconut, and oil palm, with the essential modifications to the functionality of the apps.
So moving on, which is the future improvement for our application. The main one will be enhancing our AI and also the machine learning. This is to improve our yield forecasting and also the pest prediction. Not only that, we would like to optimize our AI-driven supply chain as well. Moving on, which is the advanced crop and soil health monitoring system. We would like to implement more different types of crops and also an early AI detection for diseases and nutrition deficiency. This is to help improve the overall plantation for the farmer. Not only that, we will also integrate more IoT things and smart devices. For example, drone-based for crop monitoring and also mobile image for recognizing diseases and detection. Moving on, which is prediction model enhancement. We would like to make it more efficient in data handling, and also we would like to add some more advanced AI model feature as well. Lastly, we have some few extra potential features that might improve our app. Mainly is the voice-based AI assistant, and also maybe we would like to add some edge computing implementation for offline real-time data processing. Lastly, we would like to also make a global market development based on our application. That's all for me.